Hello everyone, welcome to another video. So this will be the third part of chapter 1, completing the square. Okay, so the prerequisites to doing this, you must know this special identities that you learned in Sec 2. Okay, so this one you must know. And then for completing the square, is basically you need to create a bracket square at some point from some expressions. Okay, so we'll dive into it later. So, okay, so eventually you need to also learn how to solve equations using completing the square, and then eventually for something more extreme, you can learn how to derive the quadratic equation that you learned in the first part. Actually, it comes from completing the square. Okay, so let's start with here. So when we say completing the square, exactly what are we talking about? I want to have like something bracket square. You can see that this is x plus 1 bracket square, this is x minus 3 bracket square, this is 4 square. So all these are called perfect square. Anything bracket square is a perfect square. So why do we want a perfect square? Because perfect square got some other benefits that you will learn in the near future. And for AMS is especially important. You deal with perfect square quite often in the near future. So it's good to learn this well. Huh? Okay, so let's start with this one. So when we say x plus 3 bracket square is a perfect square, if you write it in another way, it is just x plus 3 times x plus 3, right? So I can write it like that. Okay, so if I expand this, you will get this rainbow method, right? So I'm just going to expand this, I get this. So if you start from here, how do you actually get back here? You are actually doing cross methods. You can see that if I take this, I do the cross method, I factorize, I end up with x plus 3 times x plus 3. So cross method factorizing is actually the reverse of getting a perfect square. Okay, so from here you can get this through the cross method. Then now imagine if the expression is only x squared plus 6x instead of x squared plus 6x plus 9. So clearly this is not a perfect square, because if I factorize this, because I'm doing it here, x squared plus 6x, if I factorize, I can only take out x. So one bracket is x, the other bracket is x plus 6. So this is clearly not a perfect square. In order to make it a perfect square, if we just compare these two, I'm short of a 9. So once I plus a 9, see, this is the starting, I plus a 9, then this becomes a perfect square. I can write this as this. However, in the maths, equal sign is the bigger. So clearly these two are not equal. So if I happy go and plus a 9 here, I need to compensate by taking away a 9. And then these two are still equal. I need to maintain the equal sign, right? So, and then this 3 becomes the perfect square. The negative 9 gets left behind. And then I have created a perfect square in the expression, just that I have to use a negative 9 to offset what I added extra. So this concept and this process is called completing the square. Now, it's fair for you to ask at this point, how on earth, if I look at just this alone, how do I know I must plus 9? Why not 7? Why not 6? Why not minus 3? Alright, so 9 comes from somewhere, and there's some technique to do this, and that's what exactly we're going to learn now. Okay, so I call 9 the magic number. Actually, 9 is not exactly the magic number. 3 square and is the magic number. So 3 is the number that's important here. So you need to watch this one, this video over here. You can scan it, and then you will figure out how to do it. But in essence, we need to add a number bracket square, and we need to minus a number bracket square. How do I get this negative 6 out of nowhere is something you need to watch. Okay, so this is it. Then the next thing is so I'm assuming you have watched this already. I'm going to continue. So after you watch that, you will start to know that you need to plus minus. So the question is why I must plus then minus. So if you look at these two working here, it's important to see that this is actually the wrong working. Why? Because from here I added 3 square and I continue on, but you don't realize that these two are already not the same, but I still write equal, so I'm wrong. And whereas compared to here, I add the +3 square in order to make it a perfect square, but I still need to offset with another -3 square so that these two are still equal, and then from here these 3 terms I go and complete the square to get this. Yeah, so that's why these two are different. Okay, so the next part of this will be to actually see the real explanation of how the magic number come from. So earlier this one is just it's like a memorizing way, right? So it's a mechanical way that doesn't really understand and explain why this happens. So this video actually explains the real reason where it comes from. But I suggest that you flip to the next page, you do example 7 first. Let's get to being able to do it first. Once you are comfortable doing it, and then I suggest you come back to this video, and then from there you probably can understand it better. So that's all for this part of the video. Thank you and bye bye.